because we had the light sources like incandescent bulb earlier. After that, we have fluorescent. We have different type of compact fluorescent lamps. So those are the standard format of light sources we had. So here the color variations were also very limited. So that was basically the one cause why we are not being able to introduce varieties in a terms of intensity, in terms of color, in terms of angles. So we didn't had any that much of variation. So that's why the idea of human centric was very much required, but couldn't be implemented in a bigger way. But after development of the LEDs as a technology, I'll be sharing one very good lecture presentation from National Instruments uh, for their own LED products and also some scheme. So here we'll see the evaluation of LED. The evolution started much earlier. The evaluation of that also started in the same way. So the way we used to evaluate an LED product, say in 2000, early 2000, which was mostly used for sake of signaling purposes, mostly used for indication purposes. But now once we are evaluating LED as a general purpose light source, the parameters have changed. So that with the evolution of the LED, the evaluation of LED performance has also changed. So that is also one agenda in our curriculum. So where we will see how we can do lots of testing of the LED products, how we will be making a photometric as well as electrical parameter rating of that, and finally how we can evaluate any solid state lighting product on that context. So that is why let me just at a glance show you. I hope that this syllabus is there. I hope your screen is visible to all of you. My
Yes,
screen.
sir.
Okay, so here you know this portion is already there with you. As we all know that some syllabuses are always fixed, we are trying to focus about the syllabus, but sometimes focusing of the syllabus we need to deviate here and there because we need to expand our discussion. So that's why in my portion which I am about to cover, I'll be sharing this. So in that case, my intention, the first, the electrical characteristics of the LED, then the thermal resistance, the junction temperature, which is a crucial parameter of LED. Because once the LED came as a general purpose light source, the main challenge was the life of the LED. And the life of the LED was basically because of the junction temperature. So you need to measure the temperature of the junction, because what is LED? Let me start with that. But before that, let me finish it with then the effect of ambient temperature and electrical and photometric parameters, how they do change. LED as a source is not a standalone source. If we are talking about the LED as a light source, sometimes we need to use a module which consists of clusters of LEDs along with the driving circuit. Next, the LED driving circuit. Let me be very frank, driving a LED is the most easiest parameter because here it's just a PN junction. It's just like a diode, we know. We'll be talking about that. So that's why controlling a diode, mostly current control device we can have. So controlling a diode is much easier. A single resistance can be used to control that. So here LED, fundamental LED driver circuit starts with a resistance. So that's how you are basically controlling the actual, just like a conventional diode, we know there is a barrier potential. So that barrier potential will depend upon the different type of doping materials. So here also the barrier potentials will be there. And accordingly, the voltage we will be controlling and the current which is flowing through the LED, that should also be controlled by using the resistance only. So that is the simplest form of driving circuit. But once once the driving circuit was developed, the idea was to make this LED on. The driving circuit which was used for sake of say signaling, sake of indications, was much simpler, much easier. A single resistance, as already I have told you, can help this, because here your function is to make it on and off. But sometimes we need to think separately. Sometimes the situation may come once we need to control my LED. So here the driver has a role. Controlling of LED, we will be talking in much more detail in the coming days. In the terms of color, in the terms of voltage, in the terms of intensity, we need to control that. So in this case, a driver circuit will definitely take a very crucial role. So that circuit, whatever control circuit we need, that will be incorporated as driver circuit. And second, there is a second layer. So the first is just to make it on, the second is to make it controlled, and the third layer, which is more important, protections. Because you know that once we are using the LEDs, it's a semiconductor solid state device. It's not like a conventional light sources we have. Last semester we have seen some conventional light sources starting from the incandescent bulb. Then we have the discharge family, the fluorescent, compact fluorescent. In the higher order range, we have the sodium vapor, metal halides. So those conventional lamps to some extent are more rugged than LEDs. In which sense the term is not that appropriate, but just to make you very clear that for LED control we need to be careful about the all protection also, because you know anytime any surges even in your control circuit can destroy the LED module. So that's why we have to be very much careful about that too. So driver circuit will take care of that too. So the three part, one is to drive the LED, secondly to make a control over the LED, the voltage or color if we want to control. And the third one is basically the protection. So that is a fundamental function of the driver. Then the next part, already I've told you the evaluation of the LED products, which was not very much essential in 2010, but 2021 this is essential because we need to test LED as a single chip, LED as a module. So the module means the clusters of LED, which will make the system as a luminaire. So we'll see how in our different standards, photometric, electrical, and photometric test reports are prepared. Though in our curriculum initially, once I was in a part of making this syllabus, I was thinking that we'll be focusing about the Indian standards, but the Indian standards is mostly based upon the very important ISNA standard. Last semester we have talked about ISNA, Illumination Engineering Society of North America. So they have a very important standards which are getting followed worldwide for sake of LED testing. So that is the mother of all different country standards. So that standards we'll be talking about. We call it LM79 and LM80. So we will talk about that elaborately. And lastly, once we are talking about the solid state lighting, I personally feel the applications are very much important to know. So here some dynamic facade lightings, here some idea of other controllable lighting we will be talking about. Just an example, if you go to Amazon, so you will see there are the bulbs available on Amazon, even in the market also. That is, I'm just giving a name of one manufacturer, that is Philips Hue. So once the laboratory will be open and you can come to in a physical mode, I can take all of you to our illumination lab. I think once you all have been there in your third year, possibly in the first semester. So there I have a dedicated lab for my own research where I do work with the human performance, the EEG. And there we already have an installed Hue product. So 4 bulbs which can be controlled instantly. So we have a color palette in our mobile phone through internet or through an intranet. We can instantly create any color, any intensity. That is not something very magical. Now this is quite possible because few of our students are also working some project under us in their PhD work, developing the uh, tunable LEDs we call. That means you can tune the color whatever you are looking for. You can tune the intensity whatever you are planning for. So that means you have a big domain, you have a flexibility where you can use this much more elaborately for sake of controlling that. idea is that the mostly that product once Philips developed, that was basically they call IoT product. We all talk now talking about the IoT. By the way, am I audible? Sometimes I need to know actually.
Yes,
Yes,
sir. You're
you're
audible.
audible.
So this IoT product, and before I go to talk about this, just to share one information to all of you, that even how that product they name it Hue, HUE. You can Google it. Philips. This is IoT based lighting. So this is available on Amazon also, and that is also sometimes compatible with the Alexa. So here, what they are saying that if even in Bangalore, long back, Philips organized a hackathon. That's the way we have the Spark Hack, the similar big hackathon. From some IITs, they have developed this kind of basic concept. Taking that concept, they have funded, and that's how he was evolved. So that's why Philips have a very good feeling that this was mostly came, the idea came from the college students. So the what actually we have a device which is dedicatedly controlled by way. There is a driver circuit. So we have basically within the bulb three different RGB LEDs. So they have their dedicated driver circuits. The driver circuit is just like a conventional. It may be DC to DC conversion based. It may be we will be talking about few advanced driver circuits. So so that's why different buck converter, boost converter. So different type of conventional driver circuit. But this is absolutely a power electronic device. My question is that how this power electronic device will hamper or affect my performance. So here I am about to connect that through internet. How we can do this? There will be a router, there definitely will be a dedicated bridge circuit they used to call, but LED will be going to tuned in its own way. LED cannot be tuned through your internet. So what actually we have through internet? So this internet to us is nothing but to some extent a protocol, communication protocol, where the mode of communication, whether the signals are packets. We know today today's modern internet is IPv6 protocol. The forefather was TCP/IP protocol we used to call much earlier. Now this IPv6 packet protocols. So the packet of data is sent from my maybe my control element. It may be a computer. It may be any device like mobile phone, smartphone. So that will reach to there. But the question is that here the controlling that LED will not be done by internet. Internet is used for sake of communication protocol, and there will be a dedicated driver circuit to drive those LEDs. But here there is a interfacing block. The function of this interfacing block is to convert the signal came through IPv6 to the command what we can have to have this driver control. So that is why I am telling you this is the example we have right now. Just the way we can make IoT products how they work. So from my home I can make on and off anything to university if the flexibility is there through internet. So the same way we are controlling the light. Okay, so that's the best example how we can use this. So in this case, the best way of driver circuit R, G, B, three different categories of LED, different colors of LEDs are there. Basically, we are tuning them to form a color. Beer sir will talk about that more elaborately in SAR's portion. I have seen the color creation of LED is well explained. It is already there in the syllabus. So I am not going to talk about how this color will be generated and how the control can be done to create the colors. But my focus will be mostly in the electrical part, not to create the color, what the coordinate will be generated. So keeping that in mind, I can just show you something. So that is all about the syllabus we have. Now, I want to give you one thing. This book, if you, I will be sharing that to all of you because that is very precisely this book I am going to use. So this is a very famous book by Power Supplies for LED Drivers. So I'll be sharing that book by Steve Winder. Some portion we will be discussing from here. So that book is so authentic. We can refer for all the driving portion, driving circuit part will be discussed from here. So today I will be sending that book to all of you. So that's why I think whether I'll be able to send that book through our WhatsApp or not, that I don't know. I'll try. If the size permits, definitely I'll be trying to send it to WhatsApp. Otherwise, I will mail someone, maybe Anish or someone, you Rohit. So you can send the other this book. Okay. So this book we will be talking, we'll be referring many times. Okay. The next part, let us start about the fundamental discussion. So what actually we have in the LED? LED as a device. So evaluation of LED, if we can see, uh, that started much earlier. So it was started with the indication of light. So this was a very old method. I'm searching for the PPTs where last year I have referred. So that can help us to talk about the something, yeah, evaluation of LEDs. So in this evaluation of LED, if we can think about, so it was started with an indication type of and signaling. So that's why that was mostly a monochromatic LED. After that, it came the for driving that LED, the current was very small. So that's why the output was very small. Because here I'm just referring one presentation where the evaluation of light source, different evaluation of light sources I've mentioned.
Sir, we cannot hear you. স্যারকে ফোন কর, স্যারের নেট চলে গেছে। Yes, sir.
The interruption to my internet actually. Sometimes I didn't notice that internet got disconnected. It was showing still connected anyway. At which part we got disconnected? Can anybody tell me? Whether this slide I have shown to you, whether I have shown you the slide, a bit, little bit louder. I can't.
No, sir, you have not shown this one.
Okay, where we were talking about before that slide, whether I was talking about the, have you heard that IoT Hue products, those portion?
Yes, sir. Yes, sir.
Okay, those portion was audible. So here actually I was basically about to tell you the evolution of LEDs. So which was started much earlier during 1967. So during that time, the red LED evolved, and the idea was to use as a self-illuminating source. So what do you mean by self-illuminating source or self-glowing source? For the signaling purpose, the LEDs, for the indication purpose, the LEDs, whatever we are using, those are mostly the self-illuminating source. What does it mean? That we will never expect the light will come from that LED and reflect back to some object and we are going to see the object. Just the way in our any application, are we being able to see the lights? If somebody asks you, no, we can't see the lights. Mostly we can see the light source, and we can see the light which is reflected from some objects. So that's why if somebody say that right now I'm in a red light, yellow light, green light, or white light with the different color temperatures, that means the color appearances, whatever I'm talking about, that is reflected from some object. So that's why here that self-illuminating sources, just like those LEDs, indication LEDs, were not used for that purpose. Just the way, say, you are driving your car, here the street lights, whatever you have, what you generally see, you see the lights coming out from a street light lamp, and it will reflect back towards you, such a way you can see the road. But the traffic signals, we don't do this. It's a self-illuminating. You are about to see the lights only, the light source itself. So that was the big difference, because once the light was designed for that purpose, it was mostly designed for a very, uh, what can I say? It's a very controlled beam of light. It will not be at all distributed. So that was a challenge with a real life general purpose light source. I'm going to say real life general purpose term because this is very relevant with our discussion. If we are going to replace the general purpose light sources like the fluorescent lamp, like the incandescent bulbs, like the HID lamps, all are getting replaced with that. So we are going to talk about that. So this is basically the diversification from conventional source to the LEDs. But to make it that, the light is required to be made distributed. Last semester, we have talked a lot about mostly the distribution, different type of photometric parameters like polar curve. We have talked about the Cartesian curve. We have talked about the gonio-photometers. What we have done here also, we'll be talking about the LED, but we should ensure that the LED should definitely distribute that. But for the indication lamps, for the mostly for the traffic signal lamps, we don't need that one. It's a very concentrated beam. Your function is you are about to see that only from the different distances. So that's why the color of the LEDs are chosen such a way under different condition. Even if you have some adverse situation, weather situation, it's a foggy day, it's a very much raining, so you are supposed to see your visual scenery should not be hindered that much. But what was the advantage of those LEDs, early days LEDs? The advantage was that here the operating current is very small and the operating voltage too. So that's why mostly, the signaling LEDs were operated with a very low voltage. So how that actually was changed during early 90s, the concept came that this low wattage LEDs will not going to help. Even for the indication purposes, we need more brightness. So that means the light output will increase. But till now, we can't use the term lumen. So that's why yet high brightness LEDs, the red and also the other colors like red already was there, green, amber, everything came. So that's why we can use it for the other applications. During late 90s, the concept came that blue and green LED came with a higher brightness. So the concept was mostly to think about the color as well as to increase the output. And in 2000 onwards, the white LED came, which was basically used as an uh, comparable to the incandescent lamp efficacy. Last semester, we have talked a lot about the efficacy difference between efficiency and efficacy. There is a lumen per watt. So here it was a very poor lumen per watt, 17 lumen per watt. Let's see. So this is so small value. So it cannot be used like a general purpose source at all. But that's a white. That is the only thing. And it was a derived LED. Keep that point from today to the till the last solid state lighting classes. We should keep one thing in our mind that white LEDs are always derived LEDs. So they are not an just standalone LEDs like red, green, blue. So we have to create the white color. Even Once BRZ will talk about the color space, how we can think about the different colors, there also we'll see it's a composite color actually. So here also even we can't have a dedicated white chip which will make it on and we are going to get. So that is a combinations also. But it was a 5 millimeter LEDs then. The late 2000, the white LED with a little bit better luminous efficacy, though 70 lumen per watt is written in your slides, whatever is available to you, but that is not absolutely correct also. It was also very poor. The main advantage of LED was enjoyed there. What is the advantage? The advantage is that, first of all, this is a very small source. It's easy to handle that. Next, actually, if you don't have a big, it doesn't generate that much of heat what a conventional lamps can generate. A big light source, it can, it's a fragile in nature, you know, the glass bulb will be there. So handling, and also sometimes we need a ballast, we need a starter. So all those blocks are there. We have a very sophisticated small source and it's very lighter in weight, so we can take it here and anywhere. Even that can be driven with the battery. Even means that on that time it was about to driven by the batteries also. Late 2000 onwards, LED became a big pioneer source of solid state lighting with the application where you can integrate the solar system along with the LEDs. So that's the actual beauty of LED, how LED got evolved. Everybody's were thinking that solar energy, as we know that we are talking about the smart grid, we are talking about the distributed generations, we are talking about the solar powers. So once the solar energy was there, it's the amount of energy is not that big, number one. Number two, it's very much unpredictable. You know, never know what is going to happen in your cloudy days like today. So in this case, the only option left, if there will be a dedicated battery with a charge controller through the solar, we will be basically charging the batteries, because solar part we can't make a control with. So now the battery was supposed to drive the light source. So once this point came, the LED take the entire advantage, because here the wattage was very small. So that is how LED along with the solar become a very good package during the late 2000, say 5, 2007, during that. So all the projects were mostly thinking about LED as a general purpose sources along with the solar. You will happy to know that even we have a project in our university, that Gari Veranda we have, Aurobindo Bhavan. So, you know, this fire we used to wait. Sometimes you also assemble to show the protest like yesterday. So in that Gari Veranda, we have installed some laboratory developed LED luminaires. But on that time, it was a 5 millimeter very old LEDs with a very poor lumen output. And it was driven, it was controlled by the power supply, which is coming from the solar. So solar and this basically making the system very smooth. So if the system, but the issues were very much there, because the number one issue was the life of the LED. Within 1.5 years, suddenly the light output became 30%. So that was a great challenge. And due to that course, but the only thing why that 5 white LED became so popular, because this was very much used along with the solar system. So it will be driven by a low voltage, it will be driven by the battery. So you have enough flexibility to control it. So that is why we always think of to develop a source, we always think of to develop something which can help us to drive the LED very smoothly. So that's how the LED for general purpose came. But once the general purpose LED came, the challenges was mostly how to deal with the lumen output. It was a very low wattage, number one, and it was with a very low lumen output. So that's why that the only advantage, it was giving white light. So that's how the research came all along throughout the world. That how we can increase the light output from the LED. Here, sir, we'll talk about that, the how the energy can be converted. There are some proven method which was established all along the globe, that is photon extraction methods. How the attempt was made in earlier 2010 to increase the lumen output of the LED. And finally, today what the LED we have, that main issue with the LED has solved, that it can generate a huge lumen. So luminous flux is more. In 1970s, the LEDs, whatever we had, there was no question of measuring the luminous flux. Even during 2000, once the white LED came, lumen output was measured, but it was so poor, people were not aware of. Later, 2005 around, people were thinking of LED to use a place where you have a crisis with the conventional power. So there it will be a battery driven, so low wattage LED at least fulfill your basic requirements. So that was the idea. But now LED is becoming a silent source and it's going to replace the all conventional source. I can't share the name like with all of you. I hope in the due course in by coming week next classes we will be sharing some very interesting information about very well known cricket stadium. Well, since last 2 weeks I've got associated there to do a design. The project was LEDification. So you can't imagine that famous cricket stadium, which is basically designed with the uh, 2.5 kilowatt metal halide lamps. Now it is designed 25 numbers of 2.5 kilowatt each metal halide lamp that will be converted with the LEDs. And once I was in a part of the design, I have seen that different manufacturers, I should not quote anything, that few of the manufacturers are offering a LED luminaire, which will be used like a floodlight or sports light luminaire, which can create up to 1.8 kilowatt. Think about. So in 2007, 2008, during that LEDs were in very low wattage. It's a 10 watt LED was much bigger. We hardly used to think about there is a 10 watt LED. So if we are about to create a 30 watt luminaire, it was a huge deal to have this thermal management, to have the lumen output, but there was no option. But now 1.8 kilowatt a single LED luminaire can provide. So that's how the development has came. That's how the lumen per watt now is sometimes, according to the companies, are 100 lumen per watt. But there are the challenges too. We still have some challenges, especially the challenges with the mostly with the life, the thermal management, what we will be talking about. Uh, Here, if we come back to the basics of LED, what actually we have, this is a PN junction. We know it's just like a conventional PN junction, any type of diodes, Zener diodes or everything. If we consider what actually happens in a junction, electron and hole will recombine, and that's how the energy will come out because of the this valence bond and conduction bond. So there is that band gap energy that will release, right? Do you agree with me or not?
Yes, sir.
So that's why sometimes somebody say, yes, sir, maybe if you are very near to the computer or not, but sometimes just to make me assured that I am connected. So here mostly what happens, so if we are talking about that band gap energy, which is basically coming because of the recombination for our conventional diodes, silicon diodes, or maybe the Germanians. So that energy is mostly in a range of infrared heat. So that's why the power diodes, whatever we are using in power electronics, are having a big challenge to dissipate the heat. But for the LEDs, because of the doping material, the type of doping material we are selecting, say a very well-known doping material is gallium arsenide phosphide. So if we have that doping material, because of the doping material, the wavelength of that energy coming out of the recombination will be partly under visible band, 380 to 780 nanometer, we have already talked earlier, and the big fraction is still heat. Now, this is the research what right now is going on. How we can convert, we can reduce down that heat fraction and can increase the visible portion. So that's why more and more energy will be converted as visible. So less amount will be converted as heat. But heat is still a significant act. But once the heat is coming in a diode, conventional diode, we can use some heat sink. But here, heat sink is also used, but in a very clever way. So that we have to be always careful about. Okay. So that is the basic idea of our conventional diode, which was started with a very low flux 5 millimeter diodes. The 5 millimeter was the size of the diodes. Now to today's high flux LED chip, the concept is same here. It's a PN junction, but we need to take the type of doping materials. We are developing the different type of secondary optics. We are using different type of phosphor coating, just the way we have with the fluorescent lamp, to increase that output. So that is the basic idea, how we can convert to the conventional very low flux 1970s LEDs or 2005 white LEDs to today's this high flux LED, which is a quite comparable with the any light source starting from fluorescent lamp. Even in your very famous KCR hall, I think you haven't noticed the KCR hall tube lights are, you have already attended many classes in the KCR hall. You will happy to know that in much earlier in 2012 or 13, during that we replaced all the tube lights with the LED tubes. Now the LED tubes are there with a very high flux. In my home, I have installed a LED tube. So that is a very high flux one. Sometimes we need to control that. So that is a big part of LED, which was quite impossible 10 years, 15 years, 16 years back. But now this is possible. And at the same time, the heat, as the power of the LEDs are increasing, the example I've told you, 1.8 kilowatt, 1.5 kilowatt. So that's why the dissipation of that heat is also equally required. Okay. So I think with this today we can conclude. So if you have any queries so far about our today's discussion, you can ask me. Any query? So I think
No,
today
sir.
you have class from 12, right, Anish? Somebody from 12, you have a class?
Uh,
Okay.
Hello,
So if,
sir.
I can hear you.
Yes, sir. Sir, today I have to check once if ma'am will take or not. If she does not, then otherwise. She told that she might have some.
Okay, but today let me do one thing. Already the introductory class is there. So I am sharing that, trying to share that driver book with all of you, because that will help us to go this part much faster. And the other applications which needs more and more explanation, that part I'll be separating. So that's why here this book I'll be sharing with all of you today. So today I'm not lingering the class anymore. The next day, as I proposed, I'll be starting with the this LED, again the LED as a structure, and also the current voltage characteristics, the thermal resistance, the junction temperatures, and the LED modules, LED driving
Okay.
circuits.
Okay,
With
sir.
this, next day we will start.
Okay,
Okay,
sir.
sir.
Okay. So I think I 2 classes per week.
So let me check once.
Yes, sir.
Because BR sir have 2 classes, I have 2 classes. So accordingly, we need to decide. So if you have any query about our today's discussion, just feel free to ask, because that is also very much relevant to our next day's lecture. So any query, feel free to ask me.
Yes, sir. You have 2 hours per week, and BR sir has 2 hours per week.
Yeah. That is 4 weeks. This particular subject have 4 periods per week. Okay, this week I will not be going to take any more classes. If Saturday, if you have a slot, you let me know. I have to check my availability
Actually, many
accordingly.
teachers have told that they will take on Saturday. I can tell you on Saturday morning if
Okay,
there
okay,
is
no
slot available.
problem. So you said me, I am not giving you that I'll also be available because the Saturday I have two meetings, but you just let me know. Then it's not a problem. If I am free, I'll be able to take the class instantly.
Okay, sir. Okay,
Okay.
sir.
And any query from today's discussion?
No, sir. Today's discussion was simpler.
Yes. Okay. So next day we'll be talking about the different junction temperatures and different type of how the junction temperature can affect the photometric characteristics. We'll be talking about the photometric characteristics of LED. And then the driver part, driver portion, especially the electrical portion, the book I am going to share is much easier. We'll be talking about the different converters. I think you will be able to relate something from your power electronic classes. The buck converter, boost converter, that part's already been taught, right?
Yes, sir.
So I think I'll not spend that much of time with this. I'll be referring the book and we'll